Now, are you ready?
Perfect. I'm ready.
Okay, cool. Let's do it. We're going live, and we are live. Hello, everyone. Welcome to another meetup from the Data on Kubernetes community. We've now done over 60 meetups, and today we are with a very special person. Very excited about this one. I have seen very few people that reach the level that Saiyam has when it comes to explaining difficult concepts in such a way that even I'm able to understand them. And if I'm able to understand them, that really means a lot. So very, very nice to have you with us. As usual, you can check out in the description all the links to our Slack, to our Twitter, our link, etc. We just crossed 2,000 people on LinkedIn the other day. Very excited about that. Yay! We have another meetup this week that will be tomorrow with Matt Jarvis talking about some security related issues. But today we're going to be with Saiyam, who is no stranger to YouTube, no stranger to amazing content. I was lucky enough to participate with him in a CNCF students session that we did about a month and a half ago. Very, very, very great teacher, wonderful person, very approachable, someone who's easy to contact and has a lot of experience doing these kind of things. That being said, we were just kind of talking before we get started. This is going to be kind of a technical demo. So based on that, we'll see how we get to, if you have questions, you can always reach out to Saiyam in Twitter, the CNCF Slack, etc. But regarding questions, write your questions down in the chat. And then depending on the flow in terms of how things are going, we can address them accordingly. But before we get started, Saiyam, how are you? How's everything going?
Hey, hi, Bart, and thank you for the awesome introduction. So I'm good, and things are going well, and we are doing a lot of things for the community. So I'm really excited about that. So we planned this a lot earlier, but due to some circumstances, we were not able to do that. But today, here we are, and we definitely do this. So
that's it, man. We're here today, and this is gonna rock. So I mean, a lot of people do know you very well because you're a public person and out there a lot. But can you just give us a quick summary of your background, how you got started with working Kubernetes, what you're doing right now in Civo, just about stuff that's going on in general?
Yep. So I'll share the screen real quick because I have my demo slide that I'll share as well.
Oh, very good.
So, where is that? You're able to see, right?
Yep.
Awesome. So basically, my name is Saiyam Pathak. I'm a CNCF ambassador working as Director of Technical Evangelism at Civo. And Civo is a cloud hosting company. We have a first ever managed Kubernetes service based on K3s. So it's lightning fast, under 2 minutes, you get your cluster up and running. And we have a lot of work that we are doing more cloud native way, more Kubernetes way. So I'm part of that. So basically, as a Director of Technical Evangelism, I wear multiple hats. I participate in the marketing activities. I participate in the developer advocacy activities. I participate in supporting the SRE team, those sort of activities. I participate in the innovation activities where I try to explore the CNCF landscape, see which product fits where and how we can accommodate that in some of the problems that we are facing. So that's how I get introduced to a lot of new things. I get to work closely with the developers, be it at any of the open source project at Rancher or at SUSE or at OpenEBS and all those sort of things. So I try to engage with more and more developers, more and more folks, how things are working, where things are headed to, because that is very important. And what are the current challenges in the ecosystem? So because see, we are also having a product, but we are facing some challenges. And when we try to figure out a solution. And we try to figure out a solution based on the open source tooling. And if not, then we take sometimes support from the open source tooling, because some open source products do have their own free versions, and then they have their paid versions, which is very, very fair enough. So all sorts of things I do at work. And apart from this, I also have a YouTube channel, which you can see on the screen. So it's sayampathak.com/YouTube. So all the cloud native streams that I do over there, it's something like I have a guest on the show. Sometimes I do it all by myself. So different kind of thing. I also run CNCF minutes where I try to explain a CNCF topic in under 3, 4, 5, 7 minutes. So basically in few minutes. That is there. Also, I wrote a book on CKS, which is Certified Kubernetes Security Specialist. So I am CKA, CKAD, and CKS. And I also run official CNCF Certs Magic Show, which is every Thursday, not every Thursday, bi-weekly on Thursdays, 8:30 p.m., same time as we are now. Also, I used to run a lot of meetups in person when they was in person, and now I run everything virtually, try to engage as much as we can. And I know Data on Kubernetes is doing fantastic job. So Bart, I mean, kudos to Bart and all the hard work that he has put into build the fantastic community behind Data on Kubernetes, all the massive meetups, the super hit shows that have been put. So I'll try to make I'll try to keep up to the standards that you have built.
I have no doubt you've written a book. You're certified in absolutely everything. Also, everybody, if you haven't checked out Cloud Native TV, check out Cloud Native TV. There's some great stuff on there from awesome folks like Saiyam and others who have different programs about different stuff, but specifically focusing on the cert thing because it's very overwhelming. It's expensive. Well, I mean, it costs what it costs. It takes a lot of preparation, so you don't want to go in underprepared. Great resources out there. Now, Saiyam, how many streams do you do per week?
I do basically Monday to Friday every day.
Every day, yeah.
So basically, this particular time, so 8:30 to 9:30 IST, which is my IST is the Indian Standard Time Zone in which I am. So 8:30 to 9:30, I plan the streams. So most of my streams would be around this time. So I spend 1 hour basically learning with the community. So that's the whole idea.
Perfect. Good. With that being said, let's jump right into your demo. Let's check out what we're going to be seeing today.
Awesome. So basically today we are here to discuss about Longhorn and what Longhorn is, how it works, and I'll show you one very kind of a new demo which you might not have seen how with Cubester, another cool tool. Also, we'll talk about state in Kubernetes. We'll also talk about some of the use cases of Longhorn, and we'll also talk about how the state is changing and how the end users, because that is more important. See, we have a lot of technology out there. We have a lot of CSI drivers out there. But as an end user, I want just to run my stateful application. So that's what it is. So before we dive in, so we'll first talk about the state in Kubernetes, which is very important because from the convention, from the beginning itself, it is like Kubernetes is built for stateless, and that was true because you run their stateless application, they run fantastic because you have your pods will die and they'll spin up on another node. Now who will keep track of that state? So then sometimes, obviously, you not actually sometimes, most of the times in the application, you would need state to be persisted. Take for example Kubernetes itself. So whenever you deploy anything or create any configuration, create any YAML file, create a secret deployment pod, replica set, everything is stored in a key value pair in etcd, which is a database. So state is persisted. So state of Kubernetes itself is persisted in etcd. So every application in some or the other way would require some or the other state, at some point. Now, sometimes when you are working with stateless application, so you can go with host path. So what happens is host path is kind of a volume that can be used within the host, within the node where your workload is running. So that caters the use case. I mean, you would only use host path when you don't care, like if your pod moves from this particular node, from node A to node B. Now the host path volume have been mounted over here, but that won't be available over here. So in that scenarios where you don't care about moving, shifting here and there of the volumes in the host path, that specific use case can be taken care of. So that also can be, semi-stateless kind of application where you have some sort of state for logging purpose, for caching purpose, and all those stuff. So you can use some sort of volumes over there. But in the end, most of the application, like in the healthcare industry, banking industry, HR industry, pharmaceuticals, any industry, you would require databases or file system, etc. So when you talk about databases, they have to be persisted. Now in Kubernetes, there are a lot of concepts like stateful sets. Now, most of the times when we try to run a databases, we try to run MariaDB, MongoDB, and all those things. We run them as stateful sets. Now, stateful sets have their own benefits. We'll not go into all the benefits, but overall, like their names are predictable, and they will only be there one after the other. So means if you have 3 replicas, then if the first one is not ready, then the second one won't come up. It's not basically at the same time. So that's how the stateful set has its own characteristics, and most of the stateful, that's the name itself states like a stateful. And so databases and files. So this is one concept. Second concept in Kubernetes is Kubernetes volumes. I should write K8s actually. It's simpler, right? K8s volumes. Now in Kubernetes, you have a concept of Kubernetes volumes. Now what you can do is there are a n number of volume plugins. So what I'll do is I'll show you everything side by side so that everything is there. So Kubernetes volumes. So Kubernetes again, so volumes, like I told, is ephemeral for the container, but you need volumes so that you can persist the data. So that's the whole background, like why you need volume and all those things. So Kubernetes for any kind of volume to a given pod, uh, these things will be there. So types of volumes. Now in Kubernetes, you can see actually on the right hand side, which will be more easy for you to look. So you can see how many types of volumes are there. So, the cloud volumes are there. You have your host path, which I told you, that's also a kind of volume, but it has its own limited kind of use case. Then this is what our main goal is, like PVC and PV. Then you have, all the CSI drivers and all those things. Now what we'll do is, now we have Kubernetes volume. We are most interested in persistent volume because we want to persist the data. So persistent volume, I don't want to create as an end user or as a developer. I don't want to create. What I want to do, I will just want my application to get deployed to Kubernetes. Maximum to maximum, what I can do is I want to write a YAML spec, which I might not, but still I want to write a YAML spec where I will define the size of the volume. That's it. So basically I want this particular volume in this particular namespace. And this is the size of the volume that I need. That's all. I don't want to create the volumes, manually and all that stuff. Now, this is where your CSI drivers will come. This is where your dynamic provisioning will come, where the developer just submits a pod example, where a person will just submit this particular pod. So as a developer, I will say like I want to run a pod, and the container name is Nginx, and the port is this, and the place at where I want to mount inside the container. So this is the path which is inside your container, Nginx container. I want to mount it to this particular volume. Now this particular volume is persistent volume claim. Whoa, what is this persistent volume claim, and what does it do? What do I extra have to create? I will also specify the PVC file, which is the persistent volume claim. So this is also a Kubernetes object. So in Kubernetes object, I will say persistent volume claim. Now storage class name will be the storage drivers or the storage solution, basically, to be in more broader terms, a storage solution that the Kubernetes administrators have deployed. Now there are various storage solutions. If you see the CNCF landscape and you can go, you'll be finding OpenEBS, you'll find Longhorn, and all of the cloud providers have their own CSI drivers. Like for Civo, we have Civo Volume, which comes pre-built with K3s clusters. So you don't need actually any CSI driver. You will just submit this PVC. And even you don't specify any storage class, because most of the time the Kubernetes administrator will make your storage solution as the default storage class. So if you do not specify the storage class name, it will take the default one. Now, when it takes the default one, you specify the read write. Most of the time it is read write once, but there are some limited number of use cases for read write many, which Longhorn does support in a kind of not very straightforward way, but like this. And then you specify resource request, like how much storage I need. That's it. As a developer, I can do that's all. Now comes the storage solutions. Now here we'll talk about Longhorn. So Longhorn is a distributed storage system that will help you create the Kubernetes volume. Now, apart from creating Kubernetes volume, there are tons of features which we are going to talk now. So I hope you get the gist of where Kubernetes State is at the moment. Why do we need Kubernetes State? For the applications, how Kubernetes State is, how the stateful applications are there in, created in the Kubernetes environment. Like you create a pod, you create a PVC, both are the objects, and then your administrator, which I am for you today. So I'll be deploying a storage solution onto a Kubernetes cluster. I'll be creating a PVC. And when I create the PVC, it's the responsibility of the storage solution to create a volume for me. And it is the responsibility of the storage solution to, to have the backups, to have the snapshots, to have the disaster recovery backup, and all those sort of things. Obviously, I as an administrator would have set all those endpoints, targets, credentials, and all those things. So all these things will be taken care automatically. So I hope this particular portion, the first piece, is clear. Now let's move on to Longhorn actually. So Longhorn is, okay, I did switch to Airbnb. So Longhorn is, like I told you, is a CNCF sandbox project. It's a cloud native distributed block storage for Kubernetes. Very simple to install. I will show you. Very easy to use. Again, I will show you. Very easy to configure. Again, I will show you. Use node, Disco storage, and inbuilt UI. Again, we'll go through most of the stuff from the UI. Very fancy, very easy to operate. So basically, we want folks or the end users, or basically Longhorn. I'm not talking on the behalf, but here we are just talking about Longhorn. That's why we. So as Longhorn project, and when I deploy, so I would want my developers, or I would want as a Kubernetes administrator, that the people who are developing on Kubernetes, they do not worry about learning all the things. They can go to the UI, create the volumes very easy and configure up. They don't have to deal with the YAML files and all that stuff. So I think that's where Longhorn UI will be very helpful as well. And so it is basically a persistent container storage solution in other terms. So many uses. Now that's where I told, apart from creating the volume on the node where you have specified, or you can also tie it up to NFS server and things like that, that all those fancy things can be done, but it will be on the node. So it will be using the node disk, which can be HDD, SDD, and VME, etc. So on the node disk where your workload is running, Longhorn will create a volume on to which the persistent value claim will get a bound, and then the pod, in the pod spec we mentioned, remember, the persistent volume claim. Now that particular volume will be tied to the volume that Longhorn just created. So that's how the cycle works. We'll again go through the cycle when I show you the demo. So basically, stateful application becomes easy with Longhorn. That's pretty much straightforward. Replication, very important. Now with Longhorn, you can create replicas of your volume. So say you have, we'll do like this. Okay. Say you have, oops. Okay, let's do it here. Say you have 3 nodes, A, B, C. Now your workload is running over here and you have your volume over here. It is connected to this. Now say this particular node is gone. Now with Longhorn, you can have multiple replicas, and multiple replicas can be on different hosts. Now it kinds of proves to be your DR setup, or basically at first level, we can call it a highly available setup. So you will be having node B where you will be having the replica. Now Longhorn does have a on the particular node where the volume and the pod is, it will be having Longhorn engine, which is responsible for taking this and replicating across multiple replicas. So all the data also is in sync. So that's the responsibility of Longhorn engine. So that's where Longhorn comes into play. So Longhorn does not only create this particular volume, it will do lots of stuff. It will do the replica creation, it will do the replica sync as well. And if this goes down, then still you have the the highly available volume available. So that's how this particular portion works. Now let's move to the next point, which is replication. Now backup to external storage or NFS or media. Now what as an administrator you would want is, even if your whole cluster goes off, then there should be a backup. Now backups are very useful. You can take backup and store your volume as a backup in S3 compatible storage or NFS. Now, if you don't want to use S3, it's completely fine. You can have your own Minio solution in separate infrastructure, which is different from your Kubernetes cluster, and you can store over there. We'll do today demo of our Minio. I'll show you how to do that. You can have your NFS server set up at a different location and then do the replication. Extremely simple to do because it is very detailed, explained in the docs. I'll show you where the docs are. So that's how the backups is. So basically now when your everything goes off, your Longhorn volumes get deleted, you can restore the complete volume from the backup. And we will not do a restore, but I'll do one operation from a tool called Cubester. So that operation will test this whole functionality, this whole flow, creating a snapshot, creating a backup, restoring from a snapshot. So all these three scenarios will be covered. Next is the DR planning. Yes, of course, you can do DR planning. You can have, disaster recovery planning for your applications. Restore, obviously, when you have backed up, you'll be able to restore the data as well. And the backup scheduling snapshots. Now you can schedule your backup snapshots. Obviously, the term snapshots means they are not the exact full backups. So you have one backup, then the incremental. Sorry, then the backups after that would be incremental in nature. So basically, only the delta. So you can schedule them. I'll show you in the UI how you can do that. Smooth upgrades. So I think in v1.1.1, you can immediately update Longhorn without any downtime. I can recheck. I can double check in the release notes as well. I'll show you where to find those. So that's what Longhorn is. That's what Longhorn gives you on the table. Just a second. Bart, do we have any questions till now? We have paused, so maybe you can take something.
We're so good. No, we're good. We're good. Mainly there's people that are excited to be here. Those are the comments we've been getting.
Awesome.
Yeah.
Next up is very exciting. Now you need to understand this piece very carefully, how the Longhorn actually works within the cluster, what it actually do. So first layer, you have Kubernetes. On top of it, I will be installing Longhorn. And after that, I'll be creating pods and PVC, obviously. Now, this is the things that we have to do. Now, how this layer, the Longhorn layer works is mentioned over here. Now, we'll try to understand that. So basically, the nodes, all the nodes, on every node, there will be a manager pod. On every node, there will be a manager pod. Now, when a pod runs on every node, it's called a daemon set, a Kubernetes object. So you can say that the manager pod is a daemon set that runs on every node. And it communicates with the API server to create and manage the volumes. So as a request comes to create a volume, it will be creating a CRD, like I want a volume to be created. And then it communicates with the, whenever it receives the CRD, what it will do is, Longhorn engine does not create the, sorry, the light is gone, but it's okay. The stream will continue. So the, where I was? Yeah. So whenever the manager pod receives the custom resource, it will directly not create the volume. Instead, it will create the Longhorn engine. So this engine is basically this engine. So it will create the Longhorn engine. Now, Longhorn engine will be on the node where your actual pod will be running. So Longhorn engine will be on the node where your pod will be running. And the engine obviously is responsible for multiple things. It is responsible for all your managing the replicas and replicating between them, and the replicas getting attached to the local disk on the node, which can be SSDs, HDD, depending on which hardware or which VM or which compute you are running that. And yeah, that's pretty much it. So Longhorn engine does all the magic, and Longhorn manager manages the engine. So you can say that in a short summary, what it is there are three instances of Longhorn volume. There are three instances of Longhorn volume, and each volume has a dedicated controller, which is called Longhorn engine. So this can be called as a dedicated controller, which is a Longhorn engine, which collects which runs as a Linux process. Each Longhorn volume here has two replicas, 1 2 1 2 1 2, and these will be on, try to be on the separate nodes, as that's where it'll do the high availability thing. And the arrows figure indicate the read write data flow between the volume, then the controller instance, then the replica instance, and then the disk. So volume, controller instance, replica, disk. And by creating separate Longhorn engine for each volumes, if one controller fails, the function of other volumes is not impacted. So that's pretty simple. So if each so volume 1, which is tied to pod 1, volume 2, which is tied to pod 2. So if this engine dies, then this is not affected. So that's why we have different engines for different volumes. That's what it means. So everything that I said is mentioned in the documentation, but this is the kind of simplified version, and how things work behind the scenes. Now, yeah, we obviously with 1.1.0, actually now we have 1.1.2 RC and also 1.1.1, which is the latest release, which we'll be using today. So it has read-write many support built in, not very straightforward, I'm telling, because it's in the docs. ARM64 support, amazing. CSI snapshotter, we'll try today. Prometheus support for the metrics, which is amazing. So that's pretty much it from the theory perspective. What we'll do is we'll go. By the way, this is my YouTube channel, sayampathak.com/YouTube. You can subscribe and you can see tomorrow we are learning Rust. So if you want, you can learn, and we have series of stream lined up. Just a shameless plug. Not a shameless plug. Actually, it opened by mistake. And what we'll do is, yeah. So this is GitHub page for Longhorn, and this is the Longhorn releases. So the latest release, which is marked as the latest, you can see we have RC as well, which is a pre-release, not a release, but there are tons of features and enhancement over there as well. But let's go over some of the good enhancement, like automatic Longhorn engine upgrade. So this is very important. Then virtual machine volume support. So I think this would be with respect to a new tool called Harvester. There are multiple streams on my channel for Harvester that you can see. Yes, you can see that. Ability to use volume storage service by virtualization orchestration solution like Harvester. So that's where we have the virtual machine support. Now virtual machine would be also able to take use of Longhorn and all those things. And then we have, what we have is granular resource reservation for engines and replicas. You can specify global setting for CPU resource, IAM, Longhorn front-end UI performance improvements, and all those other features. So all these things are there, and which is good. And let's try that in action. And this is the Longhorn documentation, basically the Longhorn.io docs. So you can go over here. So Bart, I don't know if you want the links, or you can directly you are googling them side by side and sending them over.
Yeah, if you wanna drop the links here in the Zoom chat, then I can throw them in the YouTube.
Yep, I'll do that right away. Where is the chat? Interesting. Okay, here's the chat. I'll send it to panelists and the attendees.
That's perfect.
So these are the docs. This is the releases, and this is very interesting. So I'm pasting the gist, which I'll be using right now, but I'll explain you what that gist is and how that works with the demo. Okay, enough talking. Let's go to the demo and see Longhorn in action. So I hope you are able to see the terminal as well.
Yep.
Okay, font size okay.
Looks good to me, but if anybody in who's here with us on YouTube, if it doesn't look big enough, just let us know, and we'll make it bigger.
Cool. So basically, this is the cluster that I created for Bart. So kubectl get nodes. You can see that it's not very old. So we have a latest version of Kubernetes v1.21.2, which is running one control plane, 3 worker nodes, container D, and this is the complete setup basically. So you have your all the steps that I mentioned that I have done to set this cluster up, and I think it's super simple. So make sure you do that. And obviously, after the last step, you have to do kubeadm init and provide the CIDR range. So that's pretty much it, which is done. And we'll see the pods, kubectl get pods. So we have Calico as a networking solution, and you can see nothing else is there on the cluster, which is running. So now what we'll do is we'll install Longhorn. So we are installing Longhorn, and you can see the version, which is v1.1.1, which I just showed you, which is the latest one. So let's copy paste that. Very simple, right? Copy pasting. Oops, I'm able to create new. Oh, the thing is, this is stuck in terminating, so we might have to remove the finalizers. So bear with me for a second. I have that somewhere stored. Just let me, yeah. Okay, what we'll do is touch or vi live debugging, right? And we'll do this, and this is my rogue namespace, which is Longhorn system. Cool. Cat and ah, just bear with me for a couple of seconds.
It's all good.
Awesome. Okay, so we have now kubectl get ns. We don't have Longhorn, and now what we can do is we can go back to our gist. Where's that? Okay, and let's install Longhorn. So you can see it created the namespace, obviously, and then service account, all the cluster role binding, all the CRDs that is there for the engine replica settings, volumes, and then it'll also create multiple CRDs, like, and then pod security policies. Obviously, that will be deprecated in 1.1.2.25, but that will be, I think, taken care by their new project, which is Kubernetes. And then comes the part of the daemon set, which I was telling, the Longhorn manager will be running on each node as a daemon set. Then you have a Longhorn backend service, Longhorn frontend, Longhorn UI deployment and its service. And then you have the driver deployment, the Longhorn driver, the CSI one, and all these things. So let's see kubectl get pods -a. Okay, why it isn't crash will back off, we'll check in a moment. Oh, okay, sorry, because we did kubectl proxy, that's why. Cool. So what we'll do is now it should be back in a moment. Hopefully. Interesting. That is funny. Okay, its readiness probe is failing. Something recently that I did caused this weird issue, and I don't think it'll fix by default. the rest everything is working fine. Let me see if only I have this cluster or I have another cluster as well. That is interesting. So we might have to do a bit of work over here. Okay. In the meanwhile, we'll try to log into interesting. Anyways, it's taking a bit of time just because of a weird issue, but we'll do it.
Very good. Maybe while we're waiting, one of the questions that we did have is, regarding what you mentioned earlier about, certifications. How does this particular topic of PVC, things related to stateful sets and things of that nature, how do these concepts enter into certification, whether it's preparation or perhaps in the actual exam?
Yep. So you will be having the concept of Kubernetes volumes for sure. So
Okay.
Kubernetes volumes is a topic that you should be aware of. You should be aware of how to create a PVC and a PV, mount it. And there's a very good Kubernetes task. So if you go to this particular concepts and volumes, persistent volume claim, it will show you, sorry, this one, the tasks of configuring a pod container to configure PVC. And you can see I've already bookmarked this. So this is basically creating a PVC, creating a pod, attaching that to, using that PVC created over that. So I think that was that has to be done. So
Very
yeah,
good.
have to do that.
Good to know.
So we'll exit this one. And we'll go this. Yes. Awesome. So we have root demo 2. And we have demo 1. And last one is maybe demo 3. Perfect. So you can actually, you'll be able to see the cluster setup as well, which is great. And there was like, yeah, that is fine. And we'll do the exit of this. And now we will take our gist. So, okay, we are okay to take our gist, and we are okay to run that on install.sh. Now, hopefully this won't, this will run. chmod +x install. And to the third one, okay, we still have time, so it's okay. chmod +x. Let's go to, okay, which one will, cool, things are working, looks like. Where we are, demo 1, this is doing the CRI, which is okay. This is also doing the CRI1, which is fine. And in the meanwhile, what we'll do is calico cube ADM containerd setup. I think we have just the calico piece left. Yep, calico. That's it. I'll add that as well, the calico piece. Okay, so first we'll do the cube ADM init. This is on the demo 1, okay, which is fine. And after that, we will copy the calico networking. Perfect. So it will take a bit of time. I'll explain you in the meanwhile what we are going to do. So what we'll be doing is after installing all this, after installing Longhorn, we'll be installing Cubester. So Cubester is basically a tool to benchmark your Kubernetes storage Kubernetes storage solution that you have on your clusters. So benchmarking, in the sense, it does two things. First is benchmarking the performance using the FIO, which is the regular testing tool for regular performance benchmarking tool, FIO. And it will also test the snapshot and backup feature for the enabled ones. So all the Kubernetes volumes or Kubernetes storage solutions that are enabled onto the cluster, it will scan them, and it will see on which of them the CSI snapshot is working, and will print that. And then we will do a CSI a Cubester snapshot test as well. So we will be doing this particular test. So we'll be checking CSI check. So this will create a pod plus PVC. Then it will create a snapshot from that. Then it will restore from the snapshot, which is basically the backup restore functionality of Longhorn. Not only Longhorn, but in this case it's Longhorn, but it can test of any CSI one where it is enabled, where this feature is enabled. And then it will restore the pod and PVC, and then it will delete the resources. So it will do okay check, like, does the backup snapshot features work for this particular CSI storage solution that you have implemented on your cluster. After that, what you'll be doing is you will be doing a Cubester FIO, and we'll be just doing it on a 10 gigs disk. So it will create a 10 gigs of volume and do all the checks of that, which is there. Okay, so we are almost done for the, it is already downloaded all the images, which is the regular Kubernetes images 1.21. I think I hold as well. Yeah, it is set on hold. So basically what we have done till now is we have created not 4 now, we have created 3 nodes, 1 control plane, 2 will be the worker nodes. We have done all these steps to set up Kubernetes with the containerd setup. So all these things are for containerd, then swapped off the memory and then installed the what you call some of the pre-requirements like the transport, HTTPS curl, etc. And then we have the adding the packages and the key for the kubeadm, kubectl, kubeadm, and all these. Once we update, we able to we select the specific version, which is 1.21.2, and then we mark them on hold. Awesome. So we now have the Calico up and running. Oh, sorry. So we now have first node ready. We'll run few of these commands, which are mentioned over here, and done. Now we'll install our Calico. That is done. And now we'll also in the meanwhile join the nodes using the join token. And the next one. Awesome. So basically you got the fresh start to the cluster as well.
We do have a question from Sujay. Thank you very much. Does Cubester work against cloud provider storage solutions?
It should work. So if that is exposed, if it's able to find, basically, I'll do a scan. So I'll do a scan. So if it's able to find the scan, it can do all the operations mentioned in the Cubester. I'll show you that. So by now we should be having something at least. kubectl get maybe nodes. Yeah, it's not ready. That is fine. I hope it first is ready. Awesome. Oops. It's done. Okay. Come on, come on. You want already. Okay, third is also ready. And now is the second one, which is taking a little bit of time. Okay, awesome. We have a cluster up and running. It is ready. Now let's install quickly Longhorn. Done. kubectl get pods -a. Let's see now what happens. This will be interesting. Also, in the meanwhile, there was installation of few other components, which I'll explain on the go. That would be very useful, I think. Yeah, ingress controller we'll install first. So I'm also installing an ingress controller, Nginx. Okay. So Longhorn manager is still container creating because it might be downloading the image. Apart from that, all other components are running. Okay, Calico Cube controller is still container creating. We should have waited a bit, but it's okay. We can't wait too much. Okay, we have this, and let's create some of the secrets, which is fine. We can create that. So we are just creating a secret test so that we can, when we log on to the UI, we get basically the username and password prompt that we can use. So this will be the basic auth. So let's create that. And auth is created. And we'll also create ingress. Obviously, we have to create the ingress for the Longhorn UI. Okay, it's still under, sorry. Ingress has still not come up yet. Let pause. At least one manager is running somewhere. Can I see? Awesome. So at least one controller, sorry, not the Longhorn manager is running somewhere. It is still container creating. Okay, we'll still wait. And we also have the Nginx ingress controller, which is also in waiting state. So now maybe I'm tempted to do the describe. kubectl describe Longhorn system. It has started. Why it is saying it's not created? Ah, the same error. Interesting. Okay, so due to some reason, things are not working as expected. And now they are.
Yay!
Okay, so now you can see that after the manager, it has started the engines, it has started the snapshotter, resizer, and other bunch of stuffs. And right now, this is also coming up. So there is some issue that is happening with the cluster. I don't know what, which it is taking a little bit of time in doing that. Now I don't even know whether the first one succeeds. I think that one also might have gone okay in some time. No, it is still in crash to back off. Anyways, we'll not look at this cluster anymore. So let it get created for the moment then. And what are the next steps that we have? Yeah, we have the ingress that we have to create. Let's see if this gets, yeah, we have the nginx controller running now. This should get created. Okay, so we have the Longhorn ingress as well created. This is we have to do in the UI, so that is fine. In the meanwhile, let's install Cubester. So we'll install Cubester. So it's a simple call command. So you can go to the Cubester uh, releases and download for different for your operating system, like for Mac or for Linux or anything. After this, we'll untar that. Now, what I was saying is to the question that was asked earlier. So if I run Cubester, it will do a scan. So it has already scanned and it found a storage class, which is called a Longhorn. But right now, if you see, it says it didn't find any snapshot. So you can see, can't find the CSI snapshot. So this is the CSI driver, but it wasn't able to find the snapshot thing. So I cannot run this particular command as of now, which is the snapshot. So I cannot run this because it hasn't detected, because we have to enable some of the things before creating this. So those are the CRDs. So we have to go to official Kubernetes CSI external snapshotter and create some of the CSI, which is called volume snapshot classes, volume snapshots, volume snapshot contents. So all these we have to create. So let's create those. 1, 2, and 3. Next is the volume snapshot controller, which will be watching all the CRDs. So which basically custom resource will be creating. Then it will be going to the controller and controller will be doing the magic. And then this one, the first one was the RBAC. So this was the RBAC and this is the setup. So you can see the RBAC and everything got created. So till now, let's see what all things have been created. Most of the things are running. Some things are still creating, which is okay. We can wait. I mean, I think those few of the things can wait. It's okay. We'll keep continuing. Now we'll create the snapshot class. So you can see we created a snapshot class.yaml CRD. Now we are creating the custom resource. Now we are actually creating the CR. So this is created and we'll also install menu because I want to show you the backup and restore functionality. So we have the menu, we have ingress controller, we have most of the things set up. Let's run. Okay, first let's see kubectl get pods -a because I'm just creating and not checking what is running. So almost everything is running apart from the menu. Okay, menu is important because it's a backup destination. Yeah. Now we have to go to the Longhorn UI. So let's go to the Longhorn UI, which is kubectl get svc-a. Where is your ingress controller? This one. Okay, 30160. And let's go here. And we'll also go to instance. I think this is demo 1. It's okay. Proceed to visit this. Oh, I have to enter password. So this is where I was telling you it will get prompt for the username and the password. And we have given the username and the password as, I only forgot that, test and test, login. Obviously, you can give your own password. Hooray, we have the Longhorn UI. So folks, I showed you actually the, even after the failed attempts, a lot of failed attempts, we are at least able to use the, create a complete cluster from scratch. And we have the Longhorn installed on that. And we have, this is the UI. So this is the dashboard and all the events that are happening. So you can see all the events for the Longhorn system that is happening. So I'll show you the UI, but in the meanwhile, let's first run this particular command. First, let's see the pods. All pods are running. Thank God. Okay. Now to the question. We ran earlier. We didn't get this one, right? It wasn't able to get the CSI driver, but now it got the CSI driver as well. That means I can also run the CSI snapshot functionality test, which we'll definitely do right away. So let's run this particular test. Cubester CSI check. By the way, I also have a blog written on the same that you can check. Basically, it describes more on the Cubester, how it works and all those things. But this is the first time I'm demoing it kind of in a live scenario. So again, the Cubester check.
Sorry, Sam, could you link the blog as well? Could you put that in the chat so we can share?
Yep. So Cubester, if you see, my blog would be somewhere in the first page. So benchmarking Kubernetes storage using Cubester, it came, I think it came on 30th March or a couple of days back, and I posted it on the next day. So it explains like this is the cloud native storage ecosystem from the CNCF landscape. So you can see how many are there. So you can see Longhorn is listed over here. OpenEBS is there. And you can see how the ecosystem is evolving. That's to cater the needs that the end users are having. So that's why the stateful workloads are no more like it's not getting created. So it it has all the steps and all the benchmarking and all those things.
Perfect.
So post the link as well in the chat. With chat. So basically, after all the hurdles as well, we should be able to complete on time. And I'll copy this, but not paste. So what we were saying is it created the application, and let's go to the UI as well. What is happening? So let's go to the volume. So you can see the volume is already created, and also you can see it has the volume and it has the replicas. So 2 nodes are there. So 2 volumes are there. Generally, obviously, the 3 node cluster is much better. So that's why it is replica scheduling failure. It is 3. I should already have 3 node. I don't know whether this will work properly because 3 nodes is ideal. I should have done 3, but it's okay. At least some portions of that should work. And then taking a snapshot. So it is taking a snapshot. I think snapshot itself failed, right? Okay, scheduling is failed. I think snapshot is done. Let me see the events. So you can come to the volumes. You can also see the volume logs. The volume events, what is actually happening in the volume. You can on the dashboard see the volumes, how many volumes are there. In the backup, you can see, oh, we didn't do a major thing. So before visiting the backup, you have to specify the backup entry. So let's search for backup. And we have to put the backup target. And we have to put the backup secret. So this was created as part of the Minio deployment that we did. Awesome. So now if I go to the backup, this won't show the error. But now if the volume will work or not, that would be strange thing. We never know. And we can, what we can do is we can also, oops, yeah, we can also log in again to this particular node to see what is happening with the pods. So that demo one, perfect. But we do have few minutes, right? I mean, it's not a hard stop.
No, not at all.
Okay, cool.
No problem.
So you can see that in the default namespace, there's a pod which is running, Cubester CSI pod. So I didn't create that. It was created as part of the Cubester test that we are running. kubectl get pvc. You can see the pvc was created 54 seconds ago, 3 minutes 54 seconds ago, and kubectl get pv. So you can see the pv was also created, and all these things that you are seeing from that, you can see from here as well. Yeah. So the backup is created successfully. So we specified the endpoints and the backup is created. So this Minio setup can be at different location. You just provide the URL, it will back up to that Minio location or to any S3 compatible location, and also to the NFS. So all these things are documented very well in the Longhorn documentation. So if you go to the backup and restore, you can back up to a target, and there can be different targets. So AWS S3, local testing backup, which is the menu, and NFS backup restore. So you can have a number of, I mean, at least these number of solutions, which are good, I think, for backing up. So let's go to where our test is running. So our snapshot was created successfully, but the pod did not transition to running state because obviously the context deadline exceeded because we didn't set up the what you call uh, the backup target in time, and we were late in that respect. But let's do the final test. So this is also very important from end user perspective because you might be having a doubt like how each storage is performing, what is a benchmark for each storage, and that's where Cubester becomes very handy. So you can have a couple of clusters, initial POCs, you can have Cubester on that, and it will create a PVC, and then it will start running all sorts of tests on that. In the meanwhile, we'll also run this particular test in the backend. So this time, maybe it does create in the backend. Hope it has enough memory and everything. So now if we go to the dashboard, so you'll be having a volume. So all the operations that you can see, the volumes are over here, and all the operations that you can see, you can create a volume from here as well. You can select the number of replicas. Actually, by default, it's 3. That's why it is creating problem because we don't have 3 nodes. It tries to create the replicas on 3 different nodes. That's why that setup is ideal, and the volume becomes degraded. As you have seen, it becomes degraded because it do not have the right number of nodes to create the replicas for high availability. And we can also go to each of the volumes, go to the backup section. We can create the backup manually, or we can schedule the backups. So if we go to each any particular volume, you can see you can schedule the backups, take the snapshot, create backup, and also you can expand this. You can schedule the backup from, yeah, take snapshot immediately. And I hope the backup is okay. There are a few backups which are created, which is fine. And now you can create a disaster recovery volume. You can also restore from latest backup. And what else? Yeah, there are different nodes. You can have dedicated nodes only to Longhorn. So you can have like edit nodes, and you can add different things like CPU memory request. You can mark it as unschedulable as well. You can change it, will tell you the path as well. You can add a disk as well, and all those things. And then you can edit the node, enabled and disable. So disable scheduling means Longhorn controller or the engine basically which is there won't be scheduling the replicas or things on this particular node. All these things can be controlled from the UI. Obviously you can do it from the custom resources as well, because the CRDs are there. If you want to write a YAML, you can do that. All the events will be here. So all the events will be happening over here. So now let's go back. Enough of the talking. Awesome. So you can see the result came as okay. Now this means it created a pod, it created a snapshot, it restored the pod and the PVC. So the CSI checker test successfully snapshotted and restored. Now this is a very cool feature. You can test the restore and backup functionality all from this particular tool. That whether it will cater your use case, whether you will be able to take snapshot, whether you will be able to restore from a snapshot. So all these things will be very beautifully done over here. And this is also done successfully. And you can see all the IOPS. You can see the 732, which is great. And the block size of this block size, what will be the IOPS, what is the average, min, max, and for the write, read, so for read, write BW, write IOPS, and read IOPS. So you can see all the performance benchmarks you can do against different storage classes and all those things. So that pretty much sums up what I had for you to tell for today. There were some hiccups, but I hope we all learn from it. I'll obviously try to fix the other cluster and let you know what was the issue. I didn't want to do it live because time was running out, and we had a faster solution, which was just creating instances, because like Civo Cloud is fast because it will create you instances in less than 30 seconds. So we got 3 instances. We just created everything from scratch with the Kubernetes cluster, then installed Longhorn, then installed Cubester, set up Minu as the backup target. We tested the snapshot and backup functionality. We also tested the performance, and I showed you where and all settings, what all things you can do, schedule backups, do a disaster recovery, all the settings from the UI as well. So that's all in all, Longhorn brings you as a package, as a storage solution for a stateful application for Kubernetes for end users.
And all of this done at 8:30 p.m. on a Monday. So that's no small accomplishment. Before we finish, though, we do have a question from Hideout. Thank you for the question. If my pod goes down and a new pod comes to another node, what will happen to the existing volume? Will it be mounted to the new pod or will it be deleted?
Yeah, you will be having the replicas. So your volume is safe. Obviously, that's why we have that highly available architecture. So if your node completely goes down, your pod moves, it will be attached to the same volume of that replica. So you won't be facing any downtime. Your engine is responsible for syncing across your backups. Also, if you see in the volume section, so you can see it is actually degradable. Degradable means you only have 2 replicas running, so it doesn't count 2 replicas as a highly available. So you should have 3 replicas, and then it can schedule. That's why it is degradable over there.
Very, very good. That being said, Saiyam, fantastic as always. We got a lot of links. We got a lot of good stuff there. Definitely going to follow up with that blog post as well. We'll be posting that in the on Twitter and LinkedIn when we share the video of the meetup. Absolute pleasure to be with you here today. We have something for you that will be. Oh, got to get that out too. No, I did mention in the YouTube chat about your program about certs. So very, very practical for anybody out there. And it seems like it's becoming more and more in demand that companies are looking for folks with those certifications. Don't be overwhelmed. Get help. Go to resources. Check out Saiyam's TV program on the Cloud Native TV. Saiyam, we will have something for you, but we will send it later this week in social media. We'll also share it with you on Slack. Thank you very, very much for your time today. And you're very easy to find. So look, for everyone who's out there, you've got all the links. You can check out Saiyam's YouTube channel. It's got tons and tons of stuff going out there. I'm going to check out that book as well too. I think we need to do a little bit of a lottery to get that book out there too.
So yeah. So just want to tell that for any certifications or even when you are learning the new tool, so do watch out the CNCF minutes. What the main goal is in companies as well for end users. So it's not only for students, it's not only for early adopters. It's basically for anyone who is trying to find a solution, because in the CNCF landscape, for each of the problem, there are multiple solutions that people have built. Most of them will be open source, so you will get confused. So the goal here is to simplify things, at least tell you in few minutes what this particular tool does. If you find it interesting, then do a POC. Now, when you learn each tool or you learn any certification, there is a learning curve involved. Now, you will be always ending up learning something new, which is perfectly okay.
Yep. No, I think that's the point, is don't get overwhelmed, just be proactive. You know, that's the trick here. You have these resources, so use them. Also, if you want to reach out directly, I'm sure you can contact Saiyam through Civo. Kubernetes Slack, CNCF Slack. Once again, the resources are there. You just gotta don't be afraid and take advantage of them. Oh, and last but certainly not least, we want to get his Twitter in there too. Very active on Twitter as well too. When do you sleep? I suppose that should be the next question, and maybe the answer is not enough. But anyway, very, very active, very busy, and wonderful attitude. So you can't beat that. Saiyam, thank you very, very much for your time today. And we'll be definitely seeing you again in another meetup, I'm sure.
Absolutely. Thank you so much for doing this. Pleasure being on Data on Kubernetes. I always wanted to do one with you, and this is not the first and last. This is just the beginning.
Exactly. That's what we're all about. Thanks everyone to the wonderful questions in YouTube chat. We'll continue the conversations in Slack. Take care. Have a good one. Bye-bye. Cheers.
Bye.